Grade 9, week number 14, chapter number 10, circular motion. Lesson number 3, centripetal force, textbook page number 175 to 177. Lesson number 4, centripetal and centrifugal forces, textbook page number 178 to 79. Welcome, dear students. I am your physics teacher, Mr. Dimish. From these lessons, we are going to learn the factors that affect the centripetal force acting on an object and also the centrifugal force effect. Centripetal force. Object moving in a circle undergoes an acceleration that is directed to the center of the circle. A centripetal acceleration. Centripetal means toward the center. Correspondingly, the force directed toward a fixed center that causes an object to follow a circular path is called a centripetal force, like the one shown in the figure. When an object is rotating or it is moving through a circular path, the force that directed toward a fixed center is called centripetal force, and that centripetal force helps the object to follow a circular path. Examples of centripetal forces. When an automobile rounds a corner, for example, friction between the tires and the road provides the centripetal force that holds the car in a curved path. If friction is insufficient due to an oily surface, gravel, etc., the tires slide sideways and the car fails to make the curve. The car tends to skid tangentially off the road. You can see in the figure. A household example is spinning tub in an automatic washer, like the one shown in figure. In its spin cycle, the tub rotates at high speed and the tub's wall produces a centripetal force on the wet clothes, forcing them into a circular path. The holes in the tub's wall prevent the tub from exerting the same force on the water in the clothes. The water escapes tangentially out of the holes. Strictly speaking, the clothes are forced away from the water. The water is not forced away from the clothes. Calculating centripetal forces. The centripetal force on an object depends on the object's tangential speed, its mass, and the radius of its circular path. Greater the speed and greater mass require greater centripetal force. Centripetal force is equal to mass times speed square or radius of curvature. That is, Fc is equal to mv square divided by r. Centripetal force Fc is measured in newtons when m is expressed in kilograms, v in meter per second, and r in meters. Centripetal and centrifugal forces. Circular motion is described as being caused by a center-directed force. Sometimes an outward force is also attributed to circular motion. This apparent outward force on a rotating or revolving body is called centrifugal force. Centrifugal means center fleeing or away from the center. Centripetal and centrifugal forces. When you swing a tin can in a circular path, as shown in figure 10.15, there is no force pulling the can outward. Only the force from the string acts on the can to pull the can inward. The outward force is on the string, not on the can. The centrifugal force effect is attributed not to any real force but to inertia, the tendency of the moving body to follow a straight line path. Thank you for listening and have a nice day.